Okay, welcome everybody. I thought we'd start just a couple minutes early since I just got some jokes up here. I always like to start with some jokes. First one's kind of speaks for itself, right? I like the second one though. These are all over the web if you Google it. Jokes about wives with programmer husbands and they give them instructions to go to the store and it always turns out badly. You see any problems with that conclusion on that one though? Run to the store and pick up a loaf of bread. While you are there, get eggs. So the joke is, right, it's a while loop. There's no way to exit it because he's constantly getting eggs. But it assumes an unlimited supply of eggs, doesn't it? Eventually he's going to get like an invalid index exception or something like that. Okay, the third one is for all you ladies out there. Your husbands know you're always right. Last one. The last one I thought was actually applicable to the topic. So a good programmer is someone who always looks both ways before crossing a one-way street. Anybody do that? I do that because occasionally I am the one driving the wrong way down a one-way street, right? And just like in programming, in driving, I think it's wise to assume that everyone doesn't always follow the rules, right? You have to catch those occasional crazy users that do weird things with your code, or the programmer who comes in next year and makes some enhancements and calls your code in the wrong context or the wrong way that breaks things. So this session is on unit testing tips and tricks. All right, nothing forward-looking at all. Sorry about that. My name is Steve Cox. I've been in software development for about 23 years. So that's before Salesforce, it's before JUnit and all of its variations. And so I've been crazy about unit testing for a long time. I remember my first library I wrote, I was responsible for converting a code base from English only to be internationalized. And so we had to make sure we converted all the dates and times and numbers and formatted everything correctly. So what we did was we created a big unit test library that covered all the code, made sure everything passed, and then we went through and just hacked away at the code to make it internationalized, and then ran the unit tests continuously to make sure we hadn't broken things. So it was a great experience, and I was hooked. Currently, I work for Exponent Partners, which is it's a small company here in San Francisco that works for nonprofits. We do human services, coding, customizations of Salesforce, and we have an app. So today we're going to talk about why great unit testing might be an important thing and it's something you want to strive for. We'll also talk just about some kind of random utilities and tips and hints for getting 100% coverage and avoiding DML calls and stuff like that. All right, so the benefits. You always got to ask yourself, why do I want to do this, right? Is this good for me, my company, my customers? So unit testing is one of the foundations of quality assurance, right? It's part of the whole quality assurance package. So, and it's the first step, right? It's the point where the developer gets to thoroughly test the code to make sure it meets requirements, make sure there aren't bugs, make sure it handles all the exception conditions correctly before that code gets pushed out to teammates and bosses and project managers and users and everybody like that. So it's a great way to build quality into your product right up front, to find those bugs really fast and fix them really cheaply. And then it also reduces the need for those later levels of quality assurance that are a lot more expensive. Secondly, maintainability is greatly enhanced by great unit tests. So like I mentioned with that first job I had where we wrote the unit test library, if you have great unit tests, then you come back to the code to make changes later, next release, next developer comes in, whatever. You can make changes, rerun the unit tests, and have the assurance, have the peace of mind that you haven't broken your previous code. Okay, and finally, I think it's fun, personally. I really like the feeling that I have tested this code really well, it works, I know exactly how it's going to behave with all possible inputs and contexts, and it's a nice feeling, and I think it helps you to be more productive. Okay, so let's dive right into some things you can use to help out your unit testing. I'm a big fan of base classes. And who has used base classes, extended a class before? Yeah, if you haven't done it, it's a really useful way to reuse code. So if you notice line 1 there, this is a public virtual class called BaseTest. And so we will extend this with all of our other test classes, and then we'll be able to use the constants and properties and methods and all the stuff we put in here. So anything you often find yourself coding up in your unit tests, you throw in the base class, make sure it's working there, and then you can use it everywhere, right? It's a great time saver. So here's some examples. There on line 6, it's a good best practice to always use a run as user in your tests, so you know the context you're running in and the test behaves the same every time, same profile, same permissions. Down there toward the bottom, you notice it's a constructor. Don't look too closely at most of this code because it won't compile. I ripped it off from some of my personal library and didn't make all the changes I needed to. But so the base constructor here is going to call run as administrator and then call an init function, which you put all your initialization code in that function. You know, if you have things in your system that you know need to be set for every test, right? Custom settings, records that need to be in place, whatever. So here's that initialization function. It's a virtual function, right? So you can override it in a extended class and add more stuff. And then here toward the bottom, it's a little bit of a pattern that allows you to test exceptions. So we'll look at that some more later. But the basic method here, starting on line 13, we can put this call in throughout our Apex code where we have the possibility of exceptions happening. And then during our unit test, it will throw the exception, which is handy if you're trying to cover your error handling code, right? Okay, so just a little bit more here on this base test class, some other things you might want to put in it. I like to put my HTT mock classes in here, and a little method that makes it real simple, minimal typing to set up the mocking. I've cut out a lot of the code here, but you would want to implement your basic HTT callout mock class there, and then add whatever other common utility functions you use for testing. Okay, then when you actually create your unit test classes, this would be an example of one. You use the IsTest attribute, right, which makes this a test class. It's private, and it extends the base test there in line 1. Down toward the bottom, you see we have a static block that's going to run before every test is run by the system. And what that does is it creates an instance of your class, which, if you recall from the last slide, it calls init, right, and runs your initialization code. So that's a kind of a handy pattern that I like to use. All right, so moving on now from base classes, we all need to create SObjects at different times, right, to test triggers and test your logic that you've put in your Apex code. It's really handy to put all of that code for one SObject type in one place, right? You've probably all worked with code where you have 400 different places throughout the unit test where accounts are created, like they are here. I don't have line numbers. Toward the last line, right? Where you call new account and you set some properties or whatever. The problem with that is, as you all know, if a required field is added to account or a validation rule is changed, then suddenly all of your unit tests break, right? And you have to go through 30 different files to patch it up. If you put your account creation code in one place, in one public test class, then all your other test classes can call that one anytime they need to generate an account, insert an account. And then when changes happen, like we talked about, you have one place to fix that. Okay, so just in recap here, creating some utilities using a base class can save you a lot of time. It can reduce the duplication in your code, which prevents bugs, right? If you change something one place, you forget to change it the other places you have the code. And then it makes maintenance easier. Unit tests can be very self-documenting also, which helps with maintenance. Okay, this next one is a section on avoiding DML and SOQL. So Salesforce does this with callouts, right? You're all aware that you're not able to make web callouts, web service callouts from a unit test, right? Anybody know why that is? Any Salesforce people here? I don't know what the official answer is, but my guess is that web callouts are unpredictable, right? They can take a long time. You can set up a timeout period of 30 minutes, and Salesforce will just sit there pinging it until it gets an answer, right? Well, that's obviously not going to work since we're all running in a collaborative space, and I think the performance implications of that are just scary. So anyway, your unit tests are separated from web services, right? You are not allowed to mess with real web services during your unit tests. Well, that same notion can also be done with the rest of the Salesforce system, right? So you as a developer, you may not always be responsible for configuring the data model, creating fields and SObjects, validation rules, all the other stuff that goes in the Salesforce system, right? There may be other code, other triggers that work on the objects that you're currently working on. So ideally, a lot of the times, it would be nice to separate your unit tests from all of that, right? Right? Because you don't have control over a lot of it in a lot of situations. You don't care a lot about a lot of it since it's not your stuff, right? You want to test your code. So the way to do that is to not make any SOQL calls in your code and not do any DML. Kind of radical, right? But it makes for really fast running unit tests that are completely portable. You move your code to any different org and it's going to work fine as long as the right, SObjects and fields are there. Don't have any compilation errors. But something to consider if it might work in your environment. It's a nice way to be able to write tests that are really easy to maintain. So the first part of trying to accomplish that is taking existing code, which does SOQL like line 18, it does DML like line 22, and revamp that so it's more easy to test and doesn't do those things, right? So here's a rewritten version. Again, there are some compilation errors in here, I apologize. But see, the new version accepts a list of records rather than a list of IDs, right? So you already got the records, you don't need to do the SOQL. Then it does all your business logic, right? And then finally it returns an SObject that hasn't been inserted, right? So it doesn't do any DML, doesn't do any SOQL. It accepts parameters, returns something you can check, and now it's easily testable, right? You don't have to insert any opportunities to test this method now. You just create a set of them, pass them in, check the return value, and you're done. No triggers are run, no workflow rules are executed, no validation rules, nothing. Okay, so another secret to getting this to work is creating mock IDs. So some of you may be aware that you can create mock IDs, and you can use those as lookup fields and master detail relationship values, and they work just fine. All you really need is the key prefix for the SObject type, and then you just generate a number to tack onto the end. That's it, and works really well. Okay, so then your tests might look something like this. This is how mine tend to look. So the beginning, line 6, you might be testing some error conditions where exceptions get thrown, bad parameters get passed in, make sure those are all okay. And then I typically have a section with really simplistic calls, pass in an empty data array, make sure we get the right thing back. That's wrong in this case. Oh no, it's not. It's right. But anyway, don't worry about the actual code too much, just the ideas. And then a section on actual good conditions, happy paths that you'd go through to make sure things are correct. So you notice there's no SOQL in any of this. There's no DML, right? So we use our getFakeID method there in line 15 to generate an account ID to assign to the opportunity. And runs super fast and isn't dependent on the rest of the system at all. Okay, so lastly, we're going to talk about shooting for 100% coverage. which is hard, right? I think it's hard. I've been doing it for a while, and it's still really easy to say, 98%, that's all right. Nobody else cares, right? Okay, so why is 100% a good number? Whoop, it's clicked too many times. So we all know what it's like. You finish your work Friday afternoon, check it all in. They're going to deploy to production Friday night at 2 in the morning. And you just know you're going to get woken up because you got unit test failures or not enough coverage or whatever, right? So you just stay up. Well, if you're shooting for 100% coverage, you can be pretty positive that you're going to have plenty of coverage when you go to deploy that code, right? Even if things are off by a little bit, a couple of late last-minute check-ins, didn't have 100% coverage, you're still going to be good. And then, most importantly, you know what's tested, right? So if you go with the 75% minimal rule that Salesforce gives you, you know that 25% of your code is not tested. Even if you go for 90%, right? You still know if you have 10,000 lines of code, you know 1,000 lines of your code are not even touched in the unit tests, right? Maybe it's mission critical business logic, right? Maybe it has some bugs in it. You don't know because you're sitting at 90%. You're feeling proud that you've smashed Salesforce's minimum requirement, but you're still not sure all your code is tested, right? So I think 100% is good. Still tough, though. Okay, so most important with attaining this, I think, like we talked about before, you really have to design your code up front for testability. You have to have in your mind, as you write your code, how am I going to test this? Some of you may subscribe to the whole TDD thing, right? Test-driven development. That's where you write the tests first, and then you write all your code in order to until it satisfies all the tests. That's a way to go too. I don't do that personally, but design is super important. So like we talked about that one method where I showed the bad and the good. You know, it's good to have parameters that are well-defined, documented. Here's what this is. Here's what it requires. And then a return value also from most functions. Some of you have probably been involved with code where you have methods that are, 1,000 lines long, 15 levels of conditional statements, multiple SOQL statements, and DML calls, and it's really hard to unit test, right? You think, okay, I got to create these records and then attach them to these records, and after it's all done, I got to do several SOQL queries to see what's in the system. And it's horrible. So small functions with a single purpose with clearly defined inputs and outputs makes it a whole lot easier. Another tough spot in trying to attain 100% coverage is testing exceptions, like I mentioned earlier. So this little pattern, this is the testing side of that. So line 12, we set this Boolean value in the base test to say, okay, we're going to now test that an exception is thrown. And then in line 14, we're going to call our method, which you see in line 5 there of the method. That calls the base class so that when we're in testing and that Boolean value is set, we're going to throw our exception. And then, so further down within the test class, we would then check and make sure the error handling is correct, right? That we've logged the error, that we've sent an email, or whatever we're going to do to handle the error. So that's kind of a slick way to handle that. Okay, so I think that's it. Ooh, we're a little bit early, so we can do some questions if you want. But just in summary, great unit testing has terrific benefits. Those aren't always acknowledged by management or by customers because they don't know how it all works, right? But so it's part of our job as developers to educate people and to really build quality in with unit tests. Some of the stuff we've talked about today will save you a lot of time, makes testing simpler and more maintainable, and then 100% coverage gives you the total assurance that you've tested all your business logic. Okay, so that's it. If there are any questions, can take those real quick. Okay. So your question, if I understood all that right, you're asking about cases where you have multiple conditions. If the value is this, we're going to do this. If it's that, we're going to do that. Is it really necessary to test all of those? That's your question, right? Yeah. Yeah, that makes sense. So, yeah, You're questioning, what about the trade-off? How much time do you spend on unit testing? And that's a good question. I mean, we're all under time constraints, right? Every client has deadlines, and sometimes the deadlines are more important than getting 100% unit test coverage, right? So frequently we have to say, okay, I'm going to shoot for 100% on the really important business logic, maybe the really complicated stuff, to try to weed out all the bugs there. This other simplistic stuff, I know that's probably fine. I'm not going to spend time unit testing. So yeah, that's a reality. You got to be aware of that. That's a good point. Oh, specific unit testing tools. I'm not real familiar with many. I know there are a couple for Apex now, right, that people have developed using the tooling API. I think. I have not used them, though, so I'm not aware of any. For JavaScript, there are lots of libraries. Yeah, there's a JUnit variation. Anybody know what that's called? For JavaScript? I don't know. There's one that the Lightning guys recommend, a couple different testing libraries. And if a lot of your business logic is in JavaScript, then yeah, definitely you want to look at those. I didn't do any slides on those, but there are some good ones. Do some Googling and check out the Salesforce Stack Exchange, and you'll find some great ideas there. Yeah. Yeah, okay, that's a good question. So you said the place where we replace the opportunity SOQL query with just a list of objects. He says, isn't that just pushing the SOQL query to another portion of the unit test, right? Well, you saw we did write a unit test that actually didn't do a SOQL query. It just created opportunities. You could assign the fields there and pass them in. So, I mean, you do have the issue with triggers, right? Triggers do have to get run in a unit test, otherwise you can't deploy them. So you got that issue, but you could do one unit test class that just runs all your triggers and does very minimal checking on what they do, and that file has to be maintained for the rest of the system as changes are made. But then all the rest of your unit tests could just test the business logic without the actual SOQL and DML. Yeah, it's a good question though. It's not easy. I think Salesforce, in a large way, they expect unit tests to exercise the whole system, but it makes it hard, right? I'm sure you've all had lots of times where a business analyst will go in and add a required field, and suddenly everything breaks, and they say to the developer, "What's wrong with your unit tests?" Right? So it makes it hard. You're writing unit tests really for the whole team, which is not a bad thing. It's good to test the whole system also. And I think it's probably a wise thing to write unit tests that test out the validation rules and the triggers, of course, and the workflow rules. And then you've got unit tests for that stuff, right? So the idea is that you can separate those from your other business logic and have it work real well. Great, thanks. Any other questions? I think we'll call it good. Thanks very much for coming.